Bismillahirrahmanirrahim. Uh, we are going to present our project that is distributed by Madam Zanaria. Our project title is Mineral Water Distributed System. So this is our group members. Uh, my name is Amir Amsal. Second member is Ali Amshar, and last and third is Akid Irfan. Move on to the description of the system. This application is used to deliver mineral water and dispenser in the Valley area. The company's name is Persada Dunia Enterprise. The target deliveries are to universities, hospitals, and government and private office. The other use for this system is to record the deliveries throughout the day, uh, in which case the driver key hints the data for such such a mineral water to distribute throughout the location. Moving to the history of the app, the organization the company use papers and files to record for their delivery, and this will cause some miscommunication between the drivers, which lead to some missed deliveries. And also, if the hash management of the company wants to review the data or the records, it might cause some lost data in any case. Therefore, this app was used to do the job by store all the records at one place. So for this section is operation. Uh, this for data samples will be used to operate the system throughout the process. So the data samples are mineral water, dispenser, driver, and client. We're gonna use push and pop operation.
Hi, my name is Akil Irfan bin Mat Karanwa. I'm part of this project members, Minerals Water Distribution System. I'm going to explain to you guys about data structure operation that we use in this project. We use stack, and in stack itself, the operation is push and pop. So basically, in the easiest way to understand is the first data or top will be stacked by the new data. For example, build a building. At first, ground floor will be the top. And when they upgrade the new level, which is level 1, that will be the new top, which is level 1. And next is pop. Pop is removing the top data. The top data that remain behind or below become the new top. For example, they build a mall. If the mall demolish the top data, which is level 5, automatically level 4 will be the new top data or top level. For the next one, the push and pop operation take constant time. So pushing and popping, for example, B item onto the stack takes OB time, while loop iterates B time, and during each interaction, it's perform a constant amount of work processing and pushing an item. So the total time for the loop is also OB times. Therefore, the total running time of the algorithm is OB plus OB plus OB and equal to O3B, which simplify to OB times. We can conclude that the running time of the algorithm for the distribution system using a Java stack is the linear time complexity of the algorithm, make it very efficient and well suited for handling a large volume of items. Additionally, the use of stack data structure provide a simple and effective way to manage the flow of the item in a LIFO manner, ensuring the most recent received item are the first to be distributed. This also demonstrates the actual application of data structure in real-world context, as well as the advantage they provide to the system design and the optimization of the data structure itself.
Hello, my name is Anik Afshar, and I shall be explaining the output and the list interface provide the following operation for the managing lists. Firstly, the output. The collection class used in this example is the linked list class, which implements the queue interface. The queue interface provides operations such as add, remove, peek, and pull for the managing queue. The interface used are queue and list. The queue interface provides the following operation for the managing the queue. Add EE adds the specific element to the end of the queue. Offer EE adds the specific elements to the end of the queue and return true if the operation was successful. Remove removes the return an element at the head of the queue. Pull retrieves and removes the elements at the head of the queue or returns null if the queue is empty. Element retrieves but does not remove the element at the head of the queue. And finally, peek retrieves but does not remove the elements at the head of the queue or return null if the queue is empty. Next would be the list interface provides the following operation for the managing the list. Add EE adds the specific elements to the end of the list. Add int index E element, insert the specific element at the specified position in the list. Remove object O, removes the first occurrence of the specified element from the list. Removes int index, remove the element at the specified position in the list. Get int index returns the elements at the specified position in the list. Set int index E element replaces the element at the specified position in the list with the specified element. Index of object O returns the index of the first occurrence of the specified element in the list. And lastly, size return the number of elements in the list. In conclusion, in this project, we explored a computer application that uses a specific data structure, the queue, to manage the distribution of goods from a warehouse to a different location. Discuss the importance of data structures in computer science and their relevance in the real-world application, and it also showcased the practical implementation of data structure in a real-world scenario and benefits that they bring to the system design and optimization. Thank you for watching.